Alright, welcome back to Maths Methods. The other day we looked at exercise 3D, where we saw the effect transformations had on graphs. This exercise is doing everything in reverse, where you can determine the transformations that it actually took. Now, a lot of you are probably looking at these equations and you can probably see the transformations that take effect just by inspection and just looking at them. However, it's nice to have this process up our sleeve so we can actually document the steps that are taking place, especially with more complicated equations. So here is example number 9. It says here, find a sequence of transformations which takes the graph of y equals x squared to the graph of that's listed there. So essentially what you need to do is show the corresponding things that relate to each other on each side. So again, what I would do is I'd rearrange this new value or this new function with the notation with the dashes there. So we're rewriting it out, y dashed, and we've got the x dashed here. Rearranging things, moving this 3 over to this side, dividing by 2, we end up with this here. You should be able to see that this side of the equation should match up with this here, so the y should be equal to y dash take away 3 over 2, and obviously the x here matches up to this part here, x dash take away 2. So writing that out, as I've just explained, y is equal to this part, and x here is equal to this part. Listed it there. Now we're going to solve for x dashed and y dashed. It means rearranging things, which people should be happy doing. Moving the 2 over here, we end up with x dashed is equal to x plus 2. This one here, rearranging, moving the 2 over here, and then also multiplying by 2, and then obviously adding the 3. We get what y dashed is there. I'm actually listing the transformations. So the process is, the first thing that happens really is that y is multiplied by 2, and then lastly the translations happen to both x and also y. So you can see that's listed there. By doing this process in reverse, you can see that there is a transformation that is a dilation of the factor of 2 from the x-axis is the first thing that happens, and then after that there is a translation of 2 units positive in the x direction of the x-axis, and also 3 units in the positive direction of the y-axis, listed there. Here again it's asking us to find sequences of transformations going from this graph to this one here. So like what we did before, rewriting this one out with the new y and x values, so having y dashed and x dashed, which we've done there. From here, what we're doing is we're matching up what's going on. So here, this y is equal to this part here, which is y dashed, and also we've got the x here is matching up with what's underneath the square root sign, so it's equal to the 5x dash take away 2. So from there it's a matter of rearranging, and we get this here. Yes, it's a fraction, but we can deal with it, and we also know that y dash is equal to y. So in this case it says the transformation is a dilation of a factor of 1/5 from the y-axis, followed by a translation of 2/5 in a positive direction of the x-axis. Cool. Alright, looking at work example number 10. In this particular case, it's now asking us to find the sequence of transformations which takes one particular graph back to another type of graph. So there's a process that's involved here for this to happen. So here we've got the equation. For us to work out what sequences are happening, what we need to do is first of all rearrange this so that we're moving obviously the 6 back over to this side. We're taking away 6 and obviously getting rid of this 3 by dividing both sides, or multiplying by a third. That gives us y take away 6 divided by 3 is equal to 1 over x take away 1 squared. Cool. Now if we think about what's going on, here is the graph that it's being transformed to. If we rewrite this with the new notation, so we've got y dashed and also x dashed, it's going to be looking like this. And then we can match up the either side of the equations. So obviously this side here, the new y dashed is going to match up to this here, y take away 6 over 3. And here where we've got the x dashed, it's going to be this part here, which is x take away 1. From here, you can actually find out what the transformations are that take place. So you can see the first thing that happens to both y and x coordinates. The x coordinate, the first thing that happens to it is we're subtracting 1. So that means it's translating 1 unit in a negative direction. And for the y coordinate, the first thing that happens is that it is being moving 6 units in the negative direction of the y-axis. From there, after that transformation, the next thing that's happened is this is being dilated by a factor of 1/3. That's happening from the x-axis because it's happening to this y-coordinate here. Let's have a look at this last example here. Again, we've got a graph. We want to find out the transformations that take place to the graph y equals x squared. So again, rearranging this, we're moving the 6 over to this side, and then we're rewriting what it was originally with the new x and y values there. So we've got y dashed is equal to x dashed squared. From here, it's a matter of matching up the sides. So here, the left-hand side is what y dashed is going to be. So y dashed is going to be equal to y take away 6. And obviously we can see here the x dash part, the new value of x, is equal to this part here, which is 5x take away 1. So actually clearly writing that out here, check, you can see what transformations have taken place. So one of the transformations is the dilation of factor 5 from the y-axis, because that's what's happening to x here, and then it's followed by, and this is happening to both of them, a translation of a negative, or translation of 1 unit in the negative direction of the x-axis, and also a translation of 6 units in the negative direction of the y-axis here. Good luck with this exercise. Stay tuned for the next episode. Bye for now.